Next in C, we are going to see pointer to a pointer. So pointer to a pointer is a variable which is going to hold the address of another pointer. So hash include stdio.h, then int main. Here we are declaring integer variable a and I'm assigning value 5 to it. Here I'm declaring two pointer variables, asterisk p1, this is single level pointer which can hold the address of another variable, and this is asterisk p2 which is going to hold the address of another pointer variable. It cannot hold the address of simple variable. And here I'm saying p1 equals to address of a. That means if we are printing p1 or %a, both of them are going to give us address of a. So if I print f \n address of a equals to %t and one more %t, and here I'm saying p1 and here I'm saying %a. So both of these will print address of a. And if we want to print value of a, so for that printf within double quotes \n value of a equals to %t and one more %t, and here we'll say a, which is going to give value of a, and if we print asterisk p, that is also holding value of a, and here we'll give return 0. Save it, build it and run it. Here we have to print p1. So we can see that it has printed address of a equals to, both are same addresses, and value of a equals to 5 and 5 because we have printed it twice with the help of variable a directly and by asterisk p1. Now printf \n, and here I'm saying give it a line. Now here I'm saying p2, which is 2 level pointer which can hold the address of 1 level pointer. So here I have to give %p1. It cannot hold the address of a, but it can hold the address of another pointer which is level 1 pointer. And if I print either p2 or %p2, both of them will give address of p1. So here I'm writing printf address of p1 equals to %t and one more %t, and here we'll be printing comma p2, that is going to give us address of p1, comma, and %p1, this is also going to give us address of p1. Save it. We can understand this diagrammatically like this. This is integer variable a and its value is 5 and address is this. This is single level pointer, name is p1, and it is holding the address of a, that is 6422036, and here it is holding the address of a, that is 6422036, and its p1's address is 6422024, and here we have declared p2, which is 2 level pointer which is holding the address of p1. It is not holding the address of a, it is holding the address of p1. Now here if I print the value of asterisk p2, it will be address of p1. So here I'm printing printf \n, you can write directly like asterisk p2 is holding the address of P1, comma, and here I'm printing asterisk P2. Here we have to put comma, save it. So we can see that P2 asterisk P2 is holding the address of P1. Address of P1 is this. It is holding this address. But asterisk asterisk P2, that is 2 level pointer, will be holding the address of this. Sorry, value of this. That is 5. So here if I save it and run it, so you can see that asterisk P2 is holding the address of P1. We haven't printed it. You can say percentage equals to percentage D. Equals to percentage D. Save it, build it and run it. So asterisk P2 is holding address of P1. Address of P1 is 6422036 and it is holding same address. Now we have to printf \n value of A equals to percentage D and comma, if I print asterisk asterisk P2, that is going to hold value of A. Save it, then build it and then run it. So we can see that value of A equals to 5. So this pointer variable is holding the value of variable A, that is 5. And single level, that means 2 level pointer holds the address of value of single level pointer, and single value level pointer always holds the address of variable.